Today I will be explaining this flowchart that will help you identify 3D shapes. So you want to begin with start. Whenever you see an equation, you want to ask yourself, how many numbers of variables are there? If there's 2, you're going to ask, are there any 1-degree terms? Because if yes, it's a parabolic cylinder. If no, you're going to ask same coefficients. If yes, it's a circular cylinder. If no, you're going to ask, do they have the same signs? If yes, it's an elliptical cylinder. And if it's no, then it's a hyperbolic cylinder. All of these cylinders, their orientation is along the missing variable. So, for example, if there is a cylinder that is y equals ax squared, there's a 1-degree term in here, which is y, and therefore it's a parabolic cylinder. This orientation for this equation will be along the missing variable, which in this case is the z-axis. So this would be orientation along z-axis. Okay, moving on. If the number of variables, if there are 3 variables, you're going to ask yourself, are there any 1-degree terms? Because if yes, you're going to ask, do they have the same coefficients? And if there's yes over there too, you're going to know that it's a circular paraboloid. If not, you're going to ask, do they have the same signs? Because if yes, it's an elliptical paraboloid. If not, it is a hyperbolic paraboloid. And for the circular and elliptical paraboloid, their orientation will be along the 1-degree term. So, for example, if we have an equation that is x squared over a2 plus y squared over b2 equals cz, this does not have same coefficients. However, it doesn't have the same sign, so therefore it's an elliptical paraboloid. And the orientation will be along the z-axis because the z-axis is the only variable, the z variable is the only variable that has 1 degrees. For the hyperbolic paraboloid, the orientation will be along the positive term. So say for example, there is this equation, x squared over a squared minus y squared over b squared equals cz. The orientation will be along the x-axis, because if you were to set this to equal 0, you would have a negative cz, and that would be a negative term. So in this case, orientation along x-axis. Moving on. If there are no 1-degree terms, you are going to ask yourself, do they have the same coefficients? Because if yes, it's a sphere. And if it's no, you're going to ask yourself, do they have the same signs? Because if yes, it's an ellipsoid. However, if there are no same signs, you will ask, can it be set to 0? Because if yes, it will be a cone. And if it's no, then it's definitely a hyperboloid. But when you look at a hyperboloid, you need to look at the numbers of negative terms, because if there is one number of negative term, it's a hyperboloid of 1 sheet, and if there are 2 negative terms, it's a hyperboloid of 2 sheets. Now, with orientation for a sphere, we don't have orientation because it's equivalent on all sides, therefore there is no orientation. However, with an ellipsoid, the orientation will be along the largest denominator. So for example, you have x squared over a2 plus y squared over b squared plus z squared over c squared equals 1. Largest denominator if, for example, this is a 2, 2, and a 4, the orientation will be along the z-axis because the z has the largest value for the denominator. And for a cone, the orientation will be along the negative term. So for example, if you have x squared over a squared plus y squared over b squared minus z squared over c squared equals 0, the orientation will be along the z-axis because the z is the only negative term. Now, with hyperboloids, this is odd man out, which means that you're going to have an equation. For example, let's say this is an equation for a hyperboloid of 2 sheets. So b squared plus c squared over c squared equals 1, okay? The orientation will be along the z-axis because the z value is the only positive value. The rest are negative. If, say, for example, the y value is the only positive value, then the orientation will be along the y value. And with that, you know how to classify the 3D shapes.